things seem not to be going right today. Let me try to ensure that all is okay. Just a moment. Okay. Need to copy this link and then share it so that other people who joined late, who had probably lost control, can find it. I think I'll do that maybe after. Okay, so I had made a mistake. Okay, so look at this. If we go back to the documentation here, this, okay, showing duplicates was me just, maybe my mind is tired or something. I was not thinking straight. But actually, this is the request. The change is supposed to be in the response, okay, which is down here, okay. If you go down and you look at the tags, okay, this is still the request also, okay, but now using curl, okay. And I was making a mistake of looking at this, but I was supposed to look down. If you look at the response body, you see bar is not repeated. The duplicate is removed. So the duplicate is in the request, okay, but the actual output has no duplication. So this is what exactly is expected. So sorry about the breaking of the internet. Let's continue. So here they say, with this, even if you receive a request with duplicate data, it will be converted to a set of unique items. And whenever you output the data, even if the source had duplicates, it will be output as a set of unique items. And it will be annotated and documented accordingly too. So that was my bad. Things looks like a lot of things are going wrong today, but yeah, forgive me, pardon me for that. So let's go to the next topic. They're talking about nested models. They're saying each attribute of a Pydantic model has a type, okay, like a string, integer, a list of strings, and so on. But that type can itself be another Pydantic model. So they're saying, so you can declare deeply nested JSON objects with specific attribute names, types, and validations. All that are arbitrarily nested. So the first thing to achieve a nested model is we define a submodel. For example, you can define an image model. Okay, this, okay, image, class image is not a Pydantic base model because of inheriting from base model. And then we have a URL and the name of the image. Okay, so yeah, that's what we have for now. Let's go on. These others are, we already know about this. So they're saying use the sub model as a type. They're saying, and then we can use it as the type of an attribute. Okay, so you see here in this other one called item, which is also a Pydantic base model, we have image, but its type is a Pydantic base model. So this is nesting, okay, a subtype. This makes it a subtype, which is good to know. Okay, I'm glad to see that some of you have actually found this video. Sorry about the break. All right, I think I'll have to kind of linking this to the other one. All right, so yeah, simply telling us that a Pydantic base model can be a type inside another Pydantic base model. In this case, image, which is a base model, or a Pydantic base model, is a type right here inside item, which is also a base model. Okay, we know what this is, we know what the rest of these are, so I won't bore you with that. So they're saying this would mean that FastAPI would expect a body similar to this, okay? Name, description, price, tax, the tags, then image, okay, having a URL and a name, okay? In fact, we can copy it and see it for ourselves in the documentation. So guys who are watching this is simply a continuation of the other broken stream. So if I come here, you see we have the same structure. All right. So and then they say again, doing just that declaration with FastAPI, you get editor support, completion, among others, even for nested models, which is good to know. And of course, by now we are confident that FastAPI will give us stuff like this. Then they say there's data conversion, there's data validation, and automatic documentation, which of course we expect. They're saying special types and validation. They're saying apart from normal singular types like string, integer, float, among others, you can use more complex singular types that inherit from str. So they're saying to see all options, you have to check out Pydantic's type overview. You will see some examples in the next chapter. Okay. Yeah, and we're going to look at that tomorrow. For the types, for Pydantic's type overview, we can also look at it, but I think we did this later. But let us see the examples in the next tomorrow. So it's saying, for example, as in the image mode above, we have a URL field, which we have a URL field. We can declare it to be an instance of Pydantic's HTTP URL instead of str. Okay, so we have here Pydantic, where we import base model and HTTP URL. Okay, and okay, so yeah, this is good to know. Okay, so in other words, HTTP URL is what they're saying here. It's saying you can use more complex singular types that inherit from str. Like HTTP URL is a more complex singular type which inherits from str, and URL is an example. Okay, but to use it, it's inherited. I mean, it is imported from Pydantic. So instead of saying URL is an str, you put HTTP URL. And of course, by now we should know that this will give us better validation, better conversion, better automatic documentation support, editor support, etc. Okay, those are the benefits. So they're saying the string will be checked to be a valid URL and documented in JSON schema and Open API as such. Yeah, that's good actually. I don't know, because you want it to be a valid URL, not just a string. Because saying URL is a string, you don't get that valid. You only get validation for a string, but you don't get validation for it being a URL. So yeah, that's this is good. So when we continue with this, we see that we have a list images, which is a list of image or none, and default is none. Okay, again, nesting image being used here. Okay, nesting, and this is now a subtype, we can call it. Okay, actually mentioned it earlier. So if we continue, they're saying this will expect and convert and validate document etc a JSON body like. Okay, we have this, the tags, images, a list of images. Okay, so images will be a list of these kind of objects. Okay, this is the first one, this is the second one, and each of them will be made of keys, URL, a key called URL and its value, a name, its value, URL, its value, name, and its value. So basically the same thing. All right, so let's continue. They're saying, notice how the images key now has a list of image objects. Yeah, a list of image objects. So they're saying deeply nested models. You can define arbitrarily deeply nested models. Okay, so we have here image, which is a base model, item, a base model. Then we have here images, which is a list of images. Okay, and this is just nested. Then they have offer, which is a base model still. Then items. Okay, which is a list of items. Okay. But remember, items is a list of items, and item has image. Okay. Remember that item is a base model, which also has image, which is a base model. So we can nest them deeply. That's what they're trying to say. Okay. They're saying, notice how offer has a list of items, which in turn has an optional list of images. And why is it optional? Because the default value is none, like we know. Yeah, and you can actually see it from the documentation. If I copy this and paste, save, and refresh this, then I come back here, you look at the example value, okay? The same structure, okay, that we expect. So yeah, the first one, okay, for this, just to explain it to you, okay, name, description, price, then items. So name, description, price, items. An item is a list of item objects, okay? And every item has this name, description, price, tax, tags, images, but images is a list of image objects. Then we go ahead, they're saying bodies of pure lists. So saying if the top level value of the JSON body you expect is a JSON array, which is ideally Python list, you can declare the type in the parameter of the function, the same as in Pydantic models. Okay. So saying bodies of pure lists. So you're saying this is a list of images. Okay. Or in Python 3.9, you say images list. And of course, with the differences in the uppercase first letter. This first one is from typing module. This one is inbuilt into Python. So yeah, and just to give us an example here. Okay. Saying images list image, meaning images is a list of images. Okay. And of course, we know that image is a Pydantic base model. And because it's a Pydantic base model, FastAPI is smart enough to know that this should be required in the request body, or it is a request body parameter. Then we continue to say editor support everywhere. They're saying, and you get editor support everywhere for items inside of lists. Yeah, we know this, okay? Like I told you, they're just reinforcing some of these ideas again and again. But this is something we are very, very much aware of. So yeah, we know this. I won't go through this again. So you wouldn't get this kind of editor support if you're working directly with Dict instead of Pydantic models. Oh, this is good to know. This emphasizes the advantage of using Pydantic models. They're saying, but you don't have to worry about them either. Incoming dicts are converted automatically, and your output is converted automatically to JSON too. Okay. So they're saying bodies of arbitrary dicts. Okay. Yeah, very good, very good, very good to know. But you don't have to worry about them there. That incoming dictionaries are converted automatically, and our output is converted automatically to JSON too. So you're saying you can also declare a body as a dict with keys of some type and values of other type. This way you don't have to know beforehand what the valid field or attribute, as would be the case with Pydantic models. Yeah, this is nice. This would be useful if you want to receive keys that you don't already know. Okay, yeah. So ideally, you don't have to know about what keys are going to happen and their values. Okay, keys could be anything from what you could suspect or what you don't know. So saying another useful case is when you want to have keys of another type, for example, int. And I think that's what we are going to see here. In this case, you would accept any dict as long as it has int keys with float values. So let's see. Look at this. They're saying weights. Excuse me. My voice is getting rougher. Sorry. They're saying weights is a dictionary, okay, of a dictionary whose key is an integer and the value is a float. Oh, interesting. Isn't this interesting, guys? So they're saying keep in mind that JSON only supports str as keys. Yeah, actually, I was going to say this. Then they're saying, but Pydantic has automatic data conversion. They're saying the dictionary you receive as weights will actually have int keys and float values. The dictionary. But now this is in the Python code, not in the JSON. Okay, in the Python code. That's nice. So we have a recap. They're saying with FastAPI, you have the maximum flexibility provided by Pydantic models while keeping your code simple, short, and elegant. But with all benefits, editor support, we know this, guys. We have seen it. Data conversion, we have seen this. Okay. Validation, we know this. Schema documentation, automatic docs. Like, yeah, we are sure by now. We're sure about this. Okay. So yeah, we will look at how to nest models. Pretty simple. Pretty simple. The most important point there is being able to nest a model and to add metadata to a field. Okay, using the field, using body fields, using this field from Pydantic. Okay, so if you've just joined now and you've missed the stream. The first stream I did before this broke, before it broke, was actually talking about fields. Okay, we talked about fields in it. So yeah, please watch the first one, then you can watch this one. So yeah, that's it for now about fields and nested models. Tomorrow we'll start on with something different. Okay, we shall look at declare requests example data, Pydantic models, and extra JSON schema data. Yeah, so yeah, we're moving on step by step and we'll get there. Sorry about today's issue, network breaking. I hope this does not happen. Okay, I wouldn't guess this would happen. Network breaking. I hope this does not happen. Okay, I wouldn't guess this would happen on my 10th. Tomorrow should be better or even very perfect.